we talk about green tea. Green tea has been advertised as antioxidant, and millions of people are taking green tea. The word tea, the way the word resveratrol, the way the word natural is used as a marketing tool, the same way is used. I'm collecting all kinds of data in my computer. I was walking around, and during the last several months, I have found at least 15 different products in different supermarkets which are called tea. Has nothing to do by its Latin name with the tea itself, but they are called tea. It's understandable. It is just an extract coming from plant. It's not tea because the Latin name is different, but this is sold as tea. Again, it becomes a marketing tool. What are those compounds in tea? Why is it that they are advertised as antioxidants? These are phenolic compounds. The same class of compounds. They can also potentially undergo that undesirable oxidation. There are certain things which are already known about these compounds. For example, the compounds which are active in green tea, they are called catechins, right, which are the phenolic compounds. Under physiological conditions, they generate hydrogen peroxide. It's advertised as antioxidant, but under physiological conditions, it forms hydrogen peroxide. And everybody knows what is hydrogen peroxide? One of the strongest oxidizing agents in organic chemistry. Do we hear this through the TV or through the radios or through the print media? No, we don't. I have not ever. That take this tea, drink it, it is an antioxidant, but there is a chance that inside your body it will become hydrogen peroxide. If anybody has heard this, please just raise your hand. Right. It's also known in the presence of certain metal ions to damage DNA. It has a genotoxic and mutagenic impact. It's known. Papers are there. It's in the book. Explained. So it is inherently active group of compounds. So the fact that the catechin from green tea or resveratrol, when there is a proliferation of papers on resveratrol every day, praising resveratrol, it doesn't come as a surprise. For my answer to these publications, if you found their activity, then develop drug which will treat a specific medical condition or disease. We should not, given the fact it has this kind of diverse activities, ask general public to take it as preventive means. Now, look at this difference. If we have medical condition, it's called treatment. You don't have medical condition, it's called prevention. So treatment versus prevention. When we are doing treatment, it does make sense because if we are suffering from pain or any other medical condition, of course we have to take drug, no doubt about this, to treat that medical condition. And we understand that there is some price to pay, there are some side effects, but we're suffering from the pain, we're suffering from some deficiencies, we have to treat the disease. It's understandable. But for preventive purposes, we have to be very careful. For example, certain phenolic compound in some test tube experiments has shown that it slows down the growth of certain type of cancer cells, right? If this can be a justification to advise general public to take this compound, to consume it, assuming that maybe somewhere inside our bodies there is one cancer cell hiding to see when is it that catechin will show up to kill me. Where is the guarantee, unless you completely load your body with several pounds of catechin, that that particular compound will get to the right place? What if there is no cancer cell in your body? What is it exactly that we are treating? On top of it, whatever we know about oxidation I was talking about, on top of it, whatever is known already about physiological activities. If we look at the structures of compounds which are currently, today, on the market, compounds which are drugs, which went through the rigors of the FDA, they are on the shelf in the supermarket. Many of them are phenolic compounds. So these are inherently biologically active type of compounds. Now, I have a separate chapter on compounds which are currently on the market, different structures, different molecules, different diseases, just to show to the reader that these are not innocent molecules. We cannot take these molecules hoping that will prevent something. They are biologically active compounds known to undergo certain type of metabolism inside the body. Let me tell you about the concept which is called bioavailability. Bioavailability is a concept of medicinal chemistry. When you administer a certain compound into the body, after a while, you can determine in blood or serum what is the concentration of that compound. What we know about resveratrol in green tea, just to take a wild guess from 0 to 100, how much compound is still present if you check a couple of, let's say, after a while? Several percent. The rest is gone. You might think that we are taking so much resveratrol, so much green tea, it stays in the body, creates some therapeutic concentration, taking care of each and every cancer cell that shows up over there inside the body. But most of the molecules, researchers don't know what happens to those molecules. Bioavailability is very low, 2–3%, dependent upon the compounds. What is the rest? It undergoes metabolism. Again, I don't want to become too technical. There are certain reactions that it undergoes metabolism. Chemical degradations, and most probably the most dangerous oxidation reaction, which is very difficult to see unless you specifically are looking for it. Because a very sophisticated type of compounds, some of them are unstable, you need a certain type of analytical capability to look for those compounds.